user group. So I've been talking to Bill for a while now, probably about 4 months, about presenting this, and I think I'm not actually a developer, as Bill said, I'm a product manager, but I picked up some tips here from a couple of the classes, and I've been doing a lot of Googling to figure out all the pieces for Android. I think I put a pretty good product together. At least we're at a prototype now, and I got that in the back of the room, so we'll take a look at that later. So I was going to start out with a demo, but I forgot my Arduino. So I'll just kind of explain these pieces. One of the pieces I'm going to talk about today, this is a LED light strip, and it's an addressable strip. So basically what you can do is you can call any one of the LEDs and turn it on. And then you can turn on any color combination. So you could put, you do your RGB and you get 255 places with each one. So you have, I think it's like 65,000 combinations of different light colors you could make with this. So one of the things I did is I created a little Arduino program, and I'll just show that because I can't demo it today. But has anybody used Arduino before? Somebody say yeah. Okay. So this is an Arduino Micro I was using, and let's see if we got it up here. And these lights, what they let you do is, so you'll see on the back of the bike, you see the bar coming off the top screen. So the bar has the light strip going down it, and basically what it does is the Android program runs a series of lights, and then it jumps onto the light strip, and it goes down the lights. So I'm not going to be able to show you that today, but I just want to explain that piece a little bit. So what I'm able to do here is write this, write the little program, and all this program really does is it's going to take that series of lights, and it's going to have a serial interface to it. So it's going to take a serial input from the Android. And the Android is constantly just pumping numbers into it, either negative numbers or positive numbers. So what some of you looked on the screen already might see a red light going around, and it's negative right now because that screen is drawing 6 watts from the grid. And once you get on that and you start riding it, it's going to turn green because it's taking your energy and pushing it back into the wall outlet. So that's basically what the lights do. Depending on how much power you're going, you'll have a wider band of lights that go. So for every 25 watts you create, you'll have another light that goes down the strip. So we'll be able to see it in the demo today, and actually we use the machine, but this is basically the translation onto the light. So what's happening is my Android program, as it runs the loop, it's actually sending data back and forth to the light. So it's saying light element 7 and give me 5 lights after element 7. And it's doing that every 50 milliseconds. So you can see the lights kind of walking down into the outlet, back into the wall. And I had the Arduino I was going to do this demo with and then plug it onto the bike, but we won't actually be able to see that today. So I'll just keep pointing out, where that part would take place. So that's the only part I'm going to really talk about on the Arduino piece. I could have probably used something. I could have probably done it with the Android if I would have done a lot more research. Because all it is a real simple protocol to these lights. So I could have done something like with the Big Bang and just written out to the lights themselves. But nobody's done it where I could copy it on Google yet. So ideally, I would take the Arduino out. Right now, I'm just using it as a middle layer so that it can communicate to the light strip. And all I got to do is write a simple serial loop on the Android instead of having to write all that code to talk to it. So basically, all you're doing is telling it which light to light. And you'll see here that like this is sending, so you got RGB. So what I'm doing here is I'm clearing all the lights. And then depending on how much power is coming in, it's going to set a number of lights in there. And then you'll see there's a section here where I'm setting, so this is 255 where I'm green. And then the other one, if it comes in negative, it'll be 255 on the red side. So a real simple loop. All it does is take those 2 parameters and that's it. So the Android's constantly just going and running to it. Right, so with that in mind, with the LED strip and the Arduino that's laying on my desk at home, I'd be able to plug in and demo that. So I'm going to go ahead and I'm going to talk a little bit about Fit for Green, just so you have an idea for what I'm trying to do with the program. I'll talk a little bit about the whole company and idea and where we are with it so far. All right, so a quick intro. So Fit for Green started when I was in Hong Kong. As Bill said, I did my MBA in 2011. And we're on an international business residential in Hong Kong. And these are the pictures we had on all our brochures, you know, with the MBA program, trying to promote it. Hey, you get to go to Hong Kong. We went there and they had a bunch of typhoons in the area, so this is actually what we ran into. So it was terrible. It was the worst I've seen in pollution. And I really didn't realize how much pollution China was making, right? But when I went here and I got it firsthand, like even going outside, I had a sore throat. So it's pretty bad. And we were only there for 4 days, and 3 of the days were like that.
What month was that? Was it summertime or?
It was summertime.
Really?
Yeah. Yeah, I think it was in July, and there was typhoons off Japan, and then like a couple typhoons, and they were pushing everything right on top of us. So it was especially bad.
Super hot and humid too.
Yeah, it's miserable out there.
Unbearable.
But we were in Vietnam too. Vietnam was really nice, but Hong Kong was really bad. So what I ended up doing is working out inside instead, and this is kind of where the whole idea came up. So as I'm working out, I got 4 big ideas. The first thing I'm thinking was, is this pollution really bad? This bad? Is this what we have to look forward to? Because you always hear about greenhouse gas emissions, but you know, to really see it firsthand, really hit home. Next thing I started thinking about is my kids. Like, could outside right now actually be what they're in, you know, 20, 30 years from now? Is it really getting that bad? And then I thought more about the connection of fitness, like how ironic it is that I'm sitting here trying to get cardiovascular health going, and then I'm going to go breathe that stuff outside. So I'm thinking, like, what am I doing, right? It's kind of counterproductive. And then the last thing I thought was, can I turn this stuff, like, we had people all along the window looking out on Hong Kong, and they're all working out. And I think you mentioned before about the ellipticals. You were talking about all the people on the ellipticals. So I'm just seeing all these people working out, and I'm like, wow, couldn't we harness that power and at least use some of it and make a little bit of a difference? So that's when I started to do some research. And when you look at these machines, there's 3 basic elements to all these machines. They're what they call self-propelled gym equipment. So you got this part that's the generator, and the generator is the same as the brake. So as you're kicking up levels on your elliptical, the generator is getting a load on it from the controller, and it's making it a little bit harder to pedal. And then you have the console that's communicating to you how fast you're going and how much calories you're burning. So all of that math is being done on the console for you. And the part that's different here is when we introduce it, we introduce an inverter. So somebody mentioned an elliptical before. So an elliptical has a big resistor in the back. So if you take out that resistor and you put a windmill inverter in its place, you can actually suck power out of those things. So this is the same thing you would put on a windmill. The only difference is you can hook those up to 20 or 30 machines. And then of course, getting that energy back so that you can pump it back into the grid. So that's a little bit challenging with an inverter sometimes, because like a windmill inverter, you got to hook it up to either 3-phase, like a 270 or 440, or a 240 volt grid. So it's not just like plugging into the wall. You got to do some pretty major work, right, to get that all hooked up. So the machines that they worked on, the self-propelled gym machines, or anything like treadmills don't work, right? A lot of people ask me that. So there's a treadmill that's called the Curve that's self-propelled, but all the other treadmills have these big motors in them. So you can't really make that thing generate power because it's consuming power to turn your belt. But any of these ones where you're self-propelling, either the upright, the incumbent bikes, even these little hand trainers. I don't know if anybody's seen these in the gym before. Rowing machines would be another one. So any of the ones where you're actually doing all the work, that's the ones that we can tap in and get energy out of the easiest. There's some other people that did things like weight stacks, because weights you can actually put hydraulics on and then convert that into electrical energy too. But these are kind of low-hanging fruit if you're talking about fitness generated electricity. So when we did our master's degree, we started a project when I was in Hong Kong. I was thinking about all this, so we entered this business plan competition, and I'm an engineer, so we ended up building it, right? And what we did is we used the University of California, Irvine, and they had 10 of these machines, and we installed at the University of California, Irvine. So the first version, what I'm talking to you about today is the second generation. But what we did is we created a kiosk. And somebody would go up to the kiosk and log in, and there was these 10 ellipticals behind them. And then they would log in. After they log in on the kiosk, it'd say, go to elliptical 4. And you go to elliptical 4, and then you watch the screen. So we take over one of the TV screens, and we tell how much power is being created in elliptical 4. So we put a little battery up there that shows your cumulative power since you've been working out. And there's another one, it's a lightning bolt that shows you how much power you're creating right now. So you'll see down here what I had to put this little strip in here. This is a stainless steel strip, and each of these have wires coming off it. What we did is we brought them all back into this windmill inverter. So that's how we're able to create the power. So we were on Channel 7 News. It was pretty cool. We got a lot of PR out of it. The thing is, it's pretty tough to install it because I had to have electricians come in and tie that into the grid. It's a grid-tied inverter. So it's more of a kind of a promotional thing than anything that's real practical at that point. Okay, and then so this is the other screens that we had on that, and those are all the big screen TVs. A little hard to see, but real-time power versus how much power you did overall. So if you're doing 60 watts right now, right, that's your real-time watt power. And then this is watt hours. So if you do that 60 watts for a half hour, your battery will fill up to 30 watt hours. Okay. So those are your little first. What we also did is printed it out to Facebook. So I said I worked out at the ARC and I generated 108 watt hours. And then I kind of communicate what that was. So we had another one there that told your carbon gas offset, like how much carbon gas emissions you're stopping. Okay. So this is another one we did at Sacramento. We did 20 machines there. We did an installation for them. And I just want to recap this with you real quick so you can see where we are. So the big thing here, after we did the 4 installations, so I can see business-wise, I don't have enough money to stop working at Dell, but I'm starting to get myself in trouble because I have to support all these guys. Right? So I'm like, whoa, I can't do anymore. So the partners that were pulling the energy from the grid with us, they weren't getting a lot of installs. So I could see this perfect thing of going to 10 installs and then being stuck where I couldn't do what I needed to. So we pulled back on this and stopped this first generation. So one of the big things, the takeaways from that first generation is that kiosk didn't work out that good. People are working out, their heads down. They want to get on a machine. They don't want to sit there and log into anything. It takes too much time. Even when it's on the machine, a lot of people don't log in. The cost was too high. It cost about $800 per machine by the time you got that electrician in and got all your tracks laid and put the kiosk in. So it was anywhere from $800 to $1,000 per machine. So it's pretty high cost. And then the cumbersome installation, there was high voltage involved, so there was all kinds of permits you had to pull. So that's why all these things got in the way of really moving forward. Okay, so that brings us to what we're going to talk about today is the second generation. The second generation has everything built into that machine is one of them back there. So that's a bike. We have another one that's a lateral trainer, and we have another one that's an elliptical. And everything is built. This is an AC generator. So everything is built right into the machine. So as soon as you start riding that machine and put it on up above level 1, it's putting energy back into the wall outlet. So we got rid of all that high voltage stuff that was in there, and we reduced the cost a lot. So that's the big pieces on there. Has anybody looked at any of the consoles, any of the Android stuff out of China? You looked at some of the different units?
Yeah.
Because this is what's making it possible in the fitness industry. Fitness industry is all margin. So those guys make these consoles on those machines for like $100. And they got buttons on them and they got old LEDs on them, but they're pretty cheap. Now this one here, I have a 15.6-inch screen. I got this one for $450 and it's as a single unit, but they actually built it for me. They built the whole case for me, and it mounts on the machine right there. So they did all that custom work on the cabinet. So these machines coming down in price a lot, and sourcing them out of China and everything is really making them come down into the price range where they could go mainstream in the gym market. So I went a few months ago. They have URSA, it's called. It's the biggest fitness show in the country, and all the big fitness vendors come there. And the big 5 fitness vendors, they all had Android screens on some of the prototype models. There's also some Android screens to market right now. So they're starting to use these more and more. And as that price point really converges on where they are, it'll definitely be where they're using the screens more for the differentiators. It's cool, you can put Android TV on it, right? So you get the TV for free, you get a lot of the social media for free, and then they build their app kind of to control all the machines on top of that. Okay, so this is the one I got out of China, and this was my second one. My first one was a little weak on the Wi-Fi, so I had to get an antenna put on it. I didn't have any range at all on it. And my first one, I also needed an extra USB port because I used the Arduino plugin. So those are the things I had to do to get that going.
How did you find it? How did you find the console?
Alibaba? Yeah.
Serious?
Yeah, Alibaba has all of them on there, and then you just put in a quote, say I'm looking for an Android console with I'm bigger than a 14-inch screen is what I said, and then I got quotes from a bunch of people, and there's a lot of them too that'll go down. So if you want capacitive touch screens or resistive screens, all those things control the price as well. So what I have now, this one is called it's called an open frame, and so it's basically not a case, it's just a kind of a makeshift case, but the case runs you a lot of money too. When you start talking about plastic around it, that molding costs a lot. But the nice things about them, there's no cameras. Front and back cameras aren't included, right? All the other things that come on a regular tablet. And you don't have the cases either, and you got plenty of room for cooling. So all those things drive the price down for such a big screen.
Is it cheaper than the usual type of console you have on those machines that they have all LEDs on the buttons, physical, stuff they have?
Yeah, some of the big guys are only paying about $100 for those things, right?
Really?
Some of the big vendors, like Spirko is one of the big fitness providers out of Irvine, and their console is only about $100, but it's pretty dated, right?
Yeah.
Some of these, the Android ones are doing really nice graphics and all kinds of stuff.
Yeah, it's so much more flexible.
Yeah.
Are these touch screens or are they?
Yeah, they're all touch screens. A couple of them, the first couple I got were the resistive touch ones, and they were terrible. So I'd use the mouse on those anyway. But the one I got there now is pretty good. You'll check it out later.
Like old picture frames, right?
Yeah, you hear the whole glass go. That was bad. So the other parts, this is the fake Arduino that I was gonna do a little demo on, but this is a little microcontroller, and it has output lines and input lines. This is basically what I'm using to talk to the lights right now. So that would actually go down on the bike in the back inside that bar. There'd be a little Arduino in there controlling that circuitry for the lighting. These lights are pretty cool. They're about $85 for a 15-meter strip, and they come 30. Every 5 meters, you got 30 lights. So you can cut them anywhere you want. This is a piece off the 15-meter strip I bought. The other part of it is on the machine itself. So those are that's one of the pieces I'm patenting too. I'm not patenting the fact that I'm going to light some lights, but the flow of off the screen onto the light bar. I mean, that's pretty unique to the fitness industry. Nobody does that. So I was really looking to communicate that. I'm pushing back into the grid to communicate that concept really hard. And the lighting idea came up. I was thinking it Kit, for those of you who remember Knight Rider.
Yeah.
Some of you might be too young, but Knight Rider was the car in the back and forth on the car. They had the little lights to tell him, if he was talking or something was happening. So that's where I got the idea for the lighting pieces. Okay, the other piece I used, this is, so basically I have two USB ports that I'm using here, which gets a little bit tricky on some of the earlier versions of Android, but they're getting much better with it now. So this is a USB plug-in, and it talks RS-45 protocol back to the controller. So that's just the vendor that I have that's making this controller that can generate the AC power. That's not me. I get everything, like talking to the controller, communicating the console, that's all the pieces that I'm developing. Okay. So also the partner is going to provide 12 volts up. So I had to do some conversion for the Arduino to get a 5-volt supply out of there. So I had to do a little bit of other wiring to get down to cover all that.
I'm just curious, this is all digital or is it analog? The controller itself?
The controller itself, it's all, well, you're getting the RS-45 signals. So I don't know.
Digital at the time, right?
Yeah, that's all I'm sending it.
I'm curious, why didn't you go with a Raspberry Pi and instead we have you can put your Android on top?
This little controller here, because I can use regular serial commands.
So I mean, instead of the Arduino.
Well, instead of the Arduino, just the cost. Yeah, the Pi's about $90, and then
25?
$25 for a Raspberry Pi.
Well,
Yeah, Raspberry Pis are Actually, $35. Raspberry Pi 2, I just bought it.
Oh, okay.
Yeah.
Because I did look at those in the Beagle bone, is that the other one? Beagle boards. Yeah, I looked at those too, but I thought they were in the like $60 to $90 range. for
No,
those.
no, Raspberry Pis are around $35. They kept the same pricing for the new generation Raspberry Pi 2.
You just reduced it to 25.
Well, there you go.
Yeah, that's nice. So it's right in the range now because this, this one isn't for the lights. This is for the controller. This one is for the lights. That's where I'm using the Arduino on that. Yeah, this one here. That one is $22 at Radio Shack. It's a real basic microcontroller. Plus, they already had libraries to run that light strip. I don't have any libraries for the Pi.
Java. You can do everything with Java or put Android on.
Just put it. Well, Android can't talk to it either. Like this is a real stupid, simple protocol. So with the bit bang, so I had to write code. Like this one, they gave me the libraries and everything for it.
There's actually a library for Raspberry Pi that allows you to talk through the serial port.
Okay. Yeah, but
Or you can
kind of
just
like,
write the GPIO
Yeah,
directly. Actually, I have a library for C++ library for that one, writing the.
writing the bit
GPIO.
bang.
Yeah, I'm playing that.
Yeah, that's what I would have to do. But if I use the Pi, I'd still have to talk to something that can talk to the lights, right? Because I would have the same problem with the Pi as I had with the Arduino. I mean, with the Android, is that I can't talk directly to the lights.
You talk to the lights through the serial cable. Right?
No, well, I'm talking to the Arduino through the serial port, and the Arduino is programming the lights.
And that's a digital or is it an analog
It's
communication signal that you're sending out?
a digital signal that I'm sending out,
So you can do it.
but it's not a serial. It's like a real basic protocol that they had the libraries written for the Arduino already. And that's the code I brought up here was the. And you just push a real simple C program to the Arduino. And that's why I was able to write that so easily, is because they had all this written. Right, so the libraries here are actually from, I don't know if I can get it. These guys? So that's a C program. I could have probably written it in C and copied it over somehow. I got it to go out of the serial port on the Android. Ideally, if you don't go in the market, that's what I'd do. I'd have to get rid of that and go right from the Android and push it down serially. Because they can't accept a regular serial signal here. Okay, so yeah, $83 there and $25 I paid for this with all the shipping and handling and everything.
Well, what's your plan to monetize it? How do you want to monetize it?
I want to sell the individual units. So what we're working on right now is a couple of the vendors are really promoting the green technology. And we're trying to get in with those vendors right now. There's one in Indiana. There's one who has this real crazy machine. It's a lateral trainer. So it's kind of like a speed skater. You're going from side to side instead of an elliptical or a bike. There's this bike that's out of Germany. But all these machines, like all the metal bending and everything, all the physical movement, it's all out of Taiwan. So there's like a 5 square mile that builds all the fitness equipment for almost everybody. And then there's a whole other section that's China that nobody uses in the gyms yet. So China, there's like $1 billion commercial market, and then there's $1 billion home market. And China does the home market, and then Taiwan does the commercial market. So all those guys are in one area, and those are the ones I'm talking to. But I'm trying to figure out how do I fit in, because everybody's fighting for margin, right? So how do I just be a console developer for these guys? And how do I kind of own that whole platform for communicating the energy pieces? Because that's all pretty new to the industry. Everybody just puts the green energy parts in or pushes the power, but they don't really look at how, how to change the experience of the users. That's what I'm trying to do. Okay, so we'll get into some code here pretty soon. Okay, so this one, that's the RS-45 converter, plugs into USB on the back of the Android. Didn't really have that many libraries for that piece when it came for the Android. They're all Windows libraries. But the chip inside is from a company called FTDI out of the UK. That's a pretty standard chip for all the serial communications. So I was able to get those libraries and discover the device pretty easy. And then I had to mess around a little bit on the Android to get it to just differentiate. This is the Arduino, and this is the serial converter, right? Or else it doesn't know. So I had to do a lot with the vendor IDs and the product IDs so that I could differentiate the two and make different handlers for each of them. So I'll touch a little bit on that in a couple of slides here. Okay, so this is, hopefully this is helpful. I mean, has anybody done any projects where you're using a USB device on an Android? Nobody yet? Okay. So there's a special cable you have that goes the micro USB and then it converts it. So once you can discover the devices on there, and most of them, unless you're with a tablet, most of them are only going to have one USB port. I saw a couple projects out there where people are actually using USB hubs into an Android so they can get multiple devices on it and do different things with them. So. All right, so this is my first part, was pretty easy, right? Don't do the same stuff I did before. So what are we doing with this version 2 to get rid of the kiosk model and really go forward with that? So make a compelling interface, right, where people are actually using it. So I'm going to be right in their face now with everything, so I can really control what they're seeing a lot more. They don't have to look up at a screen on the wall anymore. They don't have to make that stop at a kiosk because everything is going to be local on the machine in front of them. The cost has gone down a lot because, like I said, we don't have to bring in those electricians anymore. I think at UCI it was $1,200 for the electrician alone. So across the 10 machines we did, right there, you're $120 a machine just for the guy to do the wiring. So got pretty high. And that gets rid of the high voltage part too, again, on the last piece. Okay, so what I chose, and if any of you looked on the screen in the back, is using the master detail flow template, because I wanted to keep that thing where I could see certain controls, like on the right-hand side. I never want those to go away. I never want the top parts to go away that's communicating the basic metrics, but I do want some dynamic pieces in the middle. And I got a lot of real estate on these screens because, 15.3-inch screen, you get a lot with that. So this flow worked out pretty good for me. And a lot of those, when you're doing them on the smaller handhelds, you have this piece is on another menu. It's like on your setup menu. So this one will automatically default to the big screen where it puts all the controls on the same one because it is a tablet. So all my screens are going to be 10.1 inches or more. I'm looking at another one. That's the big one. There's going to be another one that's only 10 inches. And that's on that other trainer because I don't have as much room this way to actually put the big screens there. All right, so this is when I had them design the box. I had them design the ports so that I could hide everything. I have the wires hanging at the bottom because I was going to show you guys on the demo where I'm hooking the Arduino up, and it discovers it, and it'll do different things based on whether the Arduino's there or not. But everything else will be buried inside the little cabinet before it gets bolted onto the bar. So a little bit of design on the case there that helped out a lot. Okay, so these are the basic ones, the drivers that come, and when I start up, it's going to look for the driver. So it's going to see how many of them are in there. So it's going to look for an RS-485 device by going into an info list, and it's going to look for, there's two pieces that come on all the USBs. There's a product code, and then there's a vendor code. So basically, you create a table inside your manifest file, and then you can tell it which ones you want to include. So this one with these libraries, it comes a specific list already that it's saying, hey, I see that FTDI chip, right? So when it discovers that, you can go ahead and bring that online, and then once it does find a device, it's going to go ahead and it's going to be able to set the level. So this is where I'm actually sending levels down to some of my code, which I'll show you in a little bit. Okay, so this is on that screen we saw before, right here, where it's going to set the levels from 1 to 20, and that's kind of your resistance level. So that's the basic pieces of the code that we can bring online to do that. Okay, and this is one of so now what I have to do is I have to get the information from the vendor that built the controller for the bike so that I can see which type of codes I might need to send to them. So what I'm doing is I'm just formatting regular strings, and I have a couple of different functions that build these strings, but the strings tell you which level to go to. In the level controls, this one is actually asking the controller for information. So it's asking it how much power are you generating right now, how much power are you putting back into the grid, and then how many revolutions are you going. So the revolution, so both of those are things that I want to communicate back on the machine. The revolutions, I could actually turn that into miles too. So that's basically all the vendors have all these formulas in there to say how many calories am I burning, how many miles am I going, based on all your rotations. So I had to do a little bit of calculation on a ratio here, based on all the, if you open up the side of that, there's a bunch of a pulley system that goes through there. Okay, so that's kind of the talking back and forth. That's the only three things I'm talking to that controller right now. I'm sending it a level control, and then I'm asking it for power, and I'm asking it for revolutions. And then the rest of the stuff I can do inside of my Android. All right, this is probably not going to be a lot of you guys working with RS-45, but this thing, because I'm only working on this about 2 hours a night because I have my day job, and then I might go like a week without working on it. This took me almost a month. I was stuck on trying to communicate with the RS-45 controller. So the problem with that is they have different voltage levels, and the voltage levels can, whether it's a 1 or a 0 when it's communicating. And I had a power supply that was on my Android, and then I had another power supply that was on the bike. Because when you pedal the bike, it has its own power supply. So it once you start pedaling, it switches power supplies from using the wall power to using the power you're creating. And that would throw all my levels off. So I kept thinking I had the baud rate wrong. I had something wrong with the stop bits or the data bits. But all the time it was my bias voltage. So all I had to do is make sure I'm using the same power supply for both sides of the RS-45 communication, and everything worked perfectly. So that was one of those bugs where it's really hard working one person. Like if I had another person looking on my shoulder, we probably figured it out pretty quick. But I just got jammed up on that forever. So all I saw was a lot of really flaky things going back and forth. I'm hitting the button and then the whole screen goes out, or I'm hitting the button and you'll see things jumping on the screen. So there was a lot of information coming back. It was just at all the wrong levels. Okay. The other things, when you're discovering these USB devices, there's the part where, hey, it's plugged in when I turn it on. And I got to run through and discover it and try to get the handles based on the vendor IDs and everything. There's another one where you can build a receiver. Anybody ever used those before? So basically an event receiver. And so you build this receiver, and it's almost like running a thread on its own. And it's just looking for the USB plug event. But it's not an actual thread. It's just looking for an event like that. So I created one of those in my main activity, and what I can do is when I plug in the USB, like the Arduino, or I plug in the RS-45 connector, you'll see on the screen it pops up and it says discover new device, and adding it for USB, or adding it for the LEDs, or adding it for the communication to the console. So those receivers work out really nice for it. And also in the receiver, you can build that same list, the product ID list with the vendor. And then this way you can, determine what type of device it is when it's plugged in. Okay, that took a while to figure out too, but the Stack Overflow is my friend there. a lot of people experimenting with it before. Okay, so there, like I said before, there's no Android specific docs, so you got to read between the lines on a lot of the stuff there. I was able to get different libraries from different places, and then. One of the things I had a hard time with was a check too, because when you're sending protocols back and forth to the motor, you have to do the almost like MD5, but it's called the cyclic redundancy check, and it was all written in C. So I had to figure out, I'm not an Android programmer, but I had to figure out how to switch all that stuff in Java and basically rewrite that routine for them. And then mostly everything we're sending, like we looked at before, those are all hex strings that we're sending to the device over RS-45. So a lot of conversions and stuff that went on there. Okay. So we did that. This is my mess. So it, all in that bar that we're able to stuff in there. We have, so I have the light strip coming up. The light strip's controlled by the Arduino. I had to put a 5-volt step down supply because it's 12 volts coming from the back of the bike, and I have to make sure the voltage levels are the same. And then I have my serial communication up there. So it kind of all got snipped down and bundled in and stuck down inside that bar there. So it's pretty good to be able to hide everything. So that is the basic simple LED protocol. Okay, I'm going to go through some demos now. So that's basic overview. Anybody have any questions on the pieces or the parts? Or
So this is going to replace the old boards, right? Like on the existing exercise bike.
Right.
So do you have to recreate all of the functionality they had on the other bike? Like, you know, if they had like some kind of circuit training or mountain training, do you have to recreate all that stuff?
Yeah, any of that we want, I'm going to have to recreate. So I have some basic stuff in there now. I'll show you in the demo that I played around with. And a lot of what the big thing right now is the measure itself, or there's like a term for it, but everybody wants to measure everything, right? And that's really big with all the fitness apps. So one of the things that I'm going to do is a primary concept is compare, like this is your workout now and this is your workout before, so you can kind of see where you're riding compared to other work, like your best ever, your worst ever, your average, and kind of comparing yourself from across those. So let me jump into the demo and I'll show you that piece. I keep forgetting my pads not working here.
Did you say before where you got the light strip? Was that on Alibaba also, or was that someone else?
I got that just online, at POLOLU. I just looked that up on Amazon and got those. Trying to figure out, I mean, it's not something I can use permanently because I had to protect it coming off the bike and everything. It's just kind of more of a concept thing right now. That's not going to fit on that screen, huh? I'll have to kind of put the coin in there.
Change the emulators. You can change the scale of the emulator.
Yeah, I'd have to go back and reboot it all then, right?
Yeah.
Oh. Take it back. It took a while to start the emulator.
Or we can just see like this, we can just move around.
Yeah, that's what I'll do. I'll drag it around and get it going. Stop again. Oh, it's failing on the USB pieces. Interesting. Let's try to, can't get any of the USB stuff working there. Comment that out. I actually wanted to show you that part of the code too, so I'll bring it back.
What is the actual resolution of this, on the console?
On the big screen?
Yeah.
Or on the console back there? 1280 by 6 something. But this is smaller. I think this is only 1024. I don't know what it's giving us on the overhead. Yeah. Gradle executing. Okay, let's go back here and do a little demo, and then I'll try to figure out what's going on in the emulator. Are you gonna try to do it with the camera?
Oh, yeah, where'd our cameraman go?
Okay.
Ryan.
All right, Sammy, if you can see on the good 16 right there, we'd be in trouble. So, one of the screen parts is the calories per kilowatts. This is a concept they invented at one of the schools. They started to have calories per kilowatts competition. And like sophomores against juniors against seniors, and they all competed for how much. So right now you'll see that the lights are in red. So they're drawing 7 watts out of the grid right now in order to light this console. Okay. And then once I start going and I create my power, you'll see how it changes direction. And I have 1 LED lit or 2 right now. So for every time I go 25 more watts, it's going to give me more lights. And so right now, it doesn't have, like that USB receiver didn't find the Arduino. If it found the Arduino, it would start putting data down the light strip too. So it go down this light strip and over the back and all the way back into the wall. See how the lights go back there? And then that would see, so the people would see the light shoot off the screen basically onto that track. And then what I can do here is I can track my workout. And this is tracking over time. This is where it'll lay the different results when you log in. So you'll be able to compare your results. And it's actually resizing too. So when it hits the top axis or the side axis, it'll resize the screen for you. So that you can never run out of real estate. You see the rest? So just keep it on there for you. So this is another spread. It updates that automatically for you. That didn't work out. I'm out of breath.